Hello students, welcome you all to the session 12 of the Advanced Financial Management. In this session, we'll study some simple problems on decision tree analysis, which is one of the risk measurement technique in capital budgeting decisions. The outcome of this session is to make you able to evaluate, to measure the investment proposals using this approach, that is decision tree analysis technique. In previous session, we have seen what is the meaning of decision tree analysis, how it can be used in measuring the risk of a project, and what are the steps involved in constructing a decision tree, which is a graphical representation or pictorial representation in the form of a tree with in a form of branches, where sequence of events where one event is connected to the another event, where the future happening of a future event is dependent on the previous event. Those alternatives are constructed in the form of branches until finally calculating the value of the project, that is the value of the project, and then taking decision whether to accept or reject the project. That we have seen the steps in construction, the merits of decision tree analysis, which gives a detailed insight about the various alternatives of the project, and also demerits, where it becomes a cumbersome calculation when it involves more alternatives and where the sequence of event is large. In today's session, let's solve some of the problems based on decision tree analysis. The problem goes like this. Intel company provides the following estimates of the present values of the future expected cash flows after taxes associated with investment proposal relating to plant expansion. Here the project is the plant expansion. So CFAT, its estimated CFAT is given, that is with expansion we are getting 4,50,000, 7 lakh and 5 lakh. Without expansion what we are getting is 2 lakh, 3,50,000 and 5 lakh. And probability assigned is 0.2, 0.3 and 0.5. The plant expansion cost is, if you go for expansion, the cost is 4 lakh. We are required to calculate, advise the Intel company regarding the financial feasibility, that is whether to go for expansion or be with the present status with the use of decision tree approach. We need to construct a decision tree here, whether to accept or reject, whether to go for expansion or whether or be with the present condition. That is, first is decision tree. There are two branches, that is one is expansion. The two main alternatives are, one is expansion and another is without expansion. If you go for expansion, these are the CFATs. One is 4,50,000, 7 lakh and 5 lakh. And without expansion, what we have CFAT we are getting 2 lakh, 3,50,000 and 5 lakh. The probabilities, it is same for both expansion and without expansion, that is 0.2. 0.3, 0.5, 0.2, 0.3 and 0.5. We need to calculate what is the NPV with expansion and NPV without expansion, and then we need to take a decision whether to go for a expansion or be with the present or be with without expansion. That is 4,50,000 into 0.2 plus 7 lakh into 0.3 and 5 lakh into 0.5. That comes to 5,50,000, and outflow, that is cost, is 4 lakh. So NPV is 1,50,000. Without expansion, that is 2 lakh into 0.2 plus 3,50,000 into 0.3 plus 5 lakh into 0.5, that is 3,85,000. Less cash outflow is 4 lakh. So NPV is minus 5,000. So proposed expansion is feasible. We need to go for expansion because NPV is positive, that is 1,50,000 we are getting if you go for expansion. So let's solve one more problem based on decision tree analysis. The problem is problem number 2, that is Mr. Anand is considering a new project whose cost is 20 lakh. He has estimated the project's NCFs over its 2 years as follows. So, year 1, that is 11 lakh, probability is 0.4. If we get 11 lakh, year 2 is 9 lakh, 0.6 probability, and 12 lakh, 0.4. And this is 13 lakh, 0.6 percentage, means probability of getting 11 lakh is 0.40% and probability of cutting 13 lakh is 0.6. So here, if we get 3 lakh, 13 lakh, then the probability of getting 17 lakh is 0.50% and 50% of 21 lakh. Mr. Anand's expected rate of return is 14%. Need to discount it with 14%. Evaluate the project using decision tree approach and suggest whether the project should be started or not. So, solution is cash outflow is 20 lakh. So, first two probabilities, 40% chance of getting 11 lakh and 60% chance of getting 13 lakh. If we get 11 lakh, then there is a 60% chance of getting 9 lakh and 40% chance of 12 lakh. If we get 13 lakh, there is chance of 17 lakh getting 50% and 50% chance of getting 21 lakh. So, this is path 1, this is path 2 and this is path 3 and this is path 4. Now, we need to calculate the NPV. So, path 1 is 0.6 into 0. Joint probability we need to take, that is 0.6 into that is 11 lakh into 0.877, that is 14 discount rate they have given in the problem. We need to discount it with that. 11 lakh into 0.77 plus 9 lakh into 0.769. This is this branch. This branch it is 11 lakh into 0.14% discount rate and 9 lakh into 14% discount rate for the second year. Minus 20 lakh. This is cash outflow. So 11 lakh into 0.87 is 9,64,000 and 9 lakh into 0.769 minus 20 lakh, that is we are getting 3,43,200. Second path is second branch. This is 11 lakh into discount rate, that is 0.877 and 12 lakh into discount rate 0.769 minus 20 lakh. There we have got the NPV 1,12,500. Third path is 13 lakh into 0.877 plus 17 lakh into 0.769 minus cash out 4,47,400. Fourth path is 13 lakh into 0.877 plus 21 lakh into 0.769 minus 20 lakh, we got 7,50,000. Now we need to calculate the expected NPV. That is, we need to take the joint probabilities. Here we got minus, here we got plus, here we got plus and here we got plus. So calculation of expected NPV is minus 3,43,200 into 0.24. That is 24. How you got this? This is 24 is 0.4 into 6. Next will be 0.4 into 4. Third part, this one will be 0.6 into 5. And next is 0.6 into 5. So, this 3 minus 3,43,000 is 0.24 plus 1,12,500 into 0.16. There we have calculated the joint probabilities. Another is 4,47,400 into 0.30 and last is 7,50,000 into 0.30. So this multiplied with this, we got 82,368, which is the minus figure, plus 18,000 plus 1,34,220, this product, and this is 7,55,000 into 0.3 is 2,26,500. Totally we got 2,60,350. What we did here, we have taken the two values, 13 lakh and 11 lakh and 13 lakh, and again based on those what are the future events we have taken, and then we have taken the joint probabilities. First we have discounted it, each branch we have discounted, and then we got the NPVs, and that NPVs we have further multiplied with joint probabilities to get the final NPV. So the NPV is positive, we need to accept the project. So this is about calculation of decision tree analysis. Thank you.